Hello, my lovely students. It's Miss Ranu. Today we will start with another chemistry lesson. Today I'm going to talk about the physical and chemical properties, physical and chemical change. So, chapter 2. In this lesson, you will learn about the physical and chemical properties, physical and chemical change, and it's important to understand how matter are changed and how the composition of the matter is changed also. So, today I'm going to be talking about the physical and chemical change, physical and chemical properties, and also students sometimes struggle telling about physical and chemical change. So that's why I'm going to explain each one of them, and then I will assess understanding by asking you some quick questions. And before starting, I have some few quick questions for you. At first, if water is boiling, is that a physical or chemical change? So when water is boiling, so the state it will be changing from one state into another state. When the states are changed, that means we have physical or chemical change. Please pay attention. The second question is, if we mix vinegar and baking soda, is that a physical change or chemical change? So if I try to mixing vinegar with soda or baking soda, what will happen? And what is the product that will be formed as a reaction between baking soda and vinegar? Please think about it, guys. So let's start, guys. What is matter and what are the three states of matter? Matter is anything that has mass and has volume also. So the states of matters are the physical forms in which the substance can exist. And what are the three states of matter? So we have solid, liquid, and gas. Solid particles or solid materials are rigid. They have a rigid substructure and also they have a fixed shape and fixed volume. That's why we cannot squashing them, because they are rigid and also they have fixed shape and fixed volume. And the space between the solid particles are no space. That's why they are collapsing to each other and there is no movement between the solid particles, and that's why we cannot squashing them at all. The second state is liquid state, and the liquid particles are not rigid and not fixed shape, and also they have a fixed volume. So that means that liquid particles are not rigid, they are not solid, and also they has no fixed shape. That means they has no fixed shape. If I has a bottle of the water and I pour some of water into the glass, the water will take the shape of the container that I put it inside. That's why it will take the shape of the container. That means the liquid substances don't have a fixed shape, but they have a fixed volume, and we also cannot squashing them. And what about the third state is gas state. Gas is not rigid also, and they has no fixed shape and no fixed volume, and the particles of gas are in always movement. The particles are always moving and sliding past each other, and the particles are still moving and around each other because they can be squashed, and also they has a really great spaces between the particles. They are always free and moving very easily if it's compared to the liquid and solid particles. So as I mentioned, we have two types of properties. We have physical properties and chemical properties. First of all, I'm going to talk about physical properties. Physical properties is the characteristics that can be observed without changing the substances. And we have too many physical properties. The first one, we have malleability, ductility, and also we have density and buoyancy. Guys, the physical properties are physical properties can be observed or measured without changing the composition of matter. Physical properties are used to observe or describe matter. Physical properties of matter and systems are often described as intensive and extensive properties. That means the physical properties have intensive and extensive properties. So this classification relates to the dependency of the properties upon the size of extent of the substance or object in the question. So that means we have some rules that depending on it, and then we will decide that is that change that happening to the surface of the substance, is it a physical change or chemical change, or is it a physical property or a chemical property? And also guys, we have some physical changes. Physical change, the change in a substance that does not involve a change in the identity of the substance. That means just the volume, the size and the shape of the substance will change, but the identity of the substance or the chemical composition or the arrangement of the particles will not change. That's why we call them physical change. For example, the states of matter, when the states of matter change, it means that we have physical change. For example, I have an ice cube, it will be melting to forming liquid. That means we are changing from solid to liquid. It means that we have physical change. It's still water. It doesn't change into orange juice or it doesn't change into banana juice. It's still water. And also we have a liquid change to gas. When the liquid changes to gas, it is causing another state which is called evaporation or vaporization. That means just the liquid changed from the substance changing from the liquid state into the gas. That means we don't have a great change, only the state changed from one state into another state. That means when the states of matter are changed, we have physical change because only the states are changed. Physical properties of matter, it means that, as I mentioned, physical properties of matter can be observed without changing the matter's identity or composition. Examples of physical properties, we have color, odor, mass, volume, magnetism, ability to conduct electric current or strength, and also we have flexibility. So right here we have, guys, more examples about the physical properties. We have some physical properties right here. We have thermal conductivity, we have solubility, states of matter, and also we have ductility, density, and malleability. Those are physical properties that we will learn about each one of them. So the most important physical properties that we will learn is malleability, ductility, texture, density, and buoyancy. So other physical properties of matter include hardness, malleability, ductility, melting point and boiling point, crystal form, which means structure, solubility, viscosity, and density. So guys, the first physical properties right here is malleability. Malleability is the ability of a solid substance to be hammered into thin sheets without breaking. So that means the property of a substance that describes its bent, hammered into thin sheets but without breaking, and otherwise shape it without breaking. As you know, many metals are malleable, and the metal's ability to be hammered into thin sheets or bend is called malleability. And we have different examples. We have tin and aluminum foil. Those are materials that could be malleable. The material's ability to be malleable is called malleability. And for example, the aluminum is very malleable and is why we use it to make foil to wrap our food. How we can protecting our food? By using a metal, by using aluminum foil, because aluminum foil will prevent oxidation with the food and the oxygen that's found in the environment. That's why it will preventing the oxidation reaction. And other substances like glass are not malleable. Why glasses are not malleable? Because it would break in a state of change shape. And wood is also not malleable. Why? Because it will be breaking also. While copper and tin is, or it will be described as malleable or malleability, because they will have the ability to be bent or hammered into thin sheets without breaking. The second physical property is ductility. Ductility is the physical property of material associated with the ability to be hammered thin or stretched into wire without breaking. And a ductile substance can be drawn into wire. For examples, guys, most of metals are good examples of ductile materials, including gold, silver, copper, and different types of metals that's found in the periodic table. And also we should know what is ductility and how it's measured. That ductility is defined as the ability of the material to be deformed plastically before fracturing, and measuring of ductility are elongation and reduction of area. So guys, and the most given examples right here is about the copper and silver. For example, copper can be drawn into thin wire and also use it for making electricity, and also different types of copper metal and can be stretched into a thin piece of wire. And guys, please bring a piece of paper and write what is the difference between ductility and malleability. And we have a third physical property right here is texture. Texture is how the surface of a substance feels. For example, the surface might be rough or smooth, waxy or powdery. Other properties that can be observed are malleability and ductility. So we have texture. That means we should collect information about the surface that we are touching them. Some surfaces are hard, others soft, rough, smooth, sticky, and powdery. That means the texture of the substance. And the last, guys, and we have another physical property which is called density. Density is the amount of mass that fits in a given amount of volume. The density of an object is found by dividing its mass by its volume, and that means the density of a pure water is 1 gram per ml. And if you are observing right here, we have two pictures that's describing the different densities of matter. Right here we have different stuff. We have key, we have screw, we have coins and toys, balls. If you want to testing them, if they has more density or less density, bring bowl of water and filled with water, and try to throw these materials one by one, and you will observing that the materials that has more mass, they will sink, but the materials with less mass, they will floating on the surface of the water. That's mean we have different densities of matter because of different masses. And also we have peeled and unpeeled orange right here. The first one is sinking, the second one is floating. That's mean because we have different densities and we have different masses of matter. That's why some of them are floating, others will sink. Guys, please pay attention. I'm still talking about the physical properties. The last physical property is buoyancy. So what does it mean? It means that is the ability to float in a liquid or rising gas. So a substance is buoyant if its density is less than that of the liquid or gas. So guys, look at the pictures right here. So the first one, we mean that we have a ball, and this ball is there is two types of force that acting on the same ball. One of them is buoyancy force, the second one is gravitational force. And why some objects floating? Because of the amount of the buoyancy and the gravitational force are equal. That's why those materials will floating, they will not sinking. And also buoyancy is a measure of upward force is if a fluid exerts on an object that is submerged. For example, look at the boy that is swimming right here. The buoyant force with the weight, they are on the different directions. That's why he's about to be sinking, and the water in the pool exerts an upward force that acts in a direction opposite to the boy's weight. And right here we have different cups that filled with different materials, and each one of them containing a lot of water. And so the buoyant force is upward force on an object produced by the surrounding fluids. Guys, this is all about the buoyancy, and those are the examples that I explained right now. And so we finished the physical properties and physical change. So today I'm going to talk about the chemical change. So what do we mean by chemical change and what do we mean by chemical properties? At first, we should know about the chemical change. Chemical change and chemical properties, they are the same. That means the chemical properties of matter describe its potential to undergo some chemical change or reaction by explaining the composition of each one of them. So what elements, electrons and bonding are present to give the potential for the chemical change? It's a nice question, guys. It's quite difficult to define a chemical property without using the word change. Eventually, you should be able to look at the formula of the compound and state some chemical properties. At this time, this is very difficult to do, and you are not expected to be able to do it. For example, hydrogen has the potential to ioninate and explode given the right conditions. This is a chemical property. Metals in general have the chemical property of reacting with an acid. Zinc reacts with hydrochloric acid to produce hydrogen gas. This is also a chemical property. That's why a chemical property, it means that a property of matter that describes a substance's ability to participate in a chemical reactions. any substances that participating in any chemical reactions, that means we will get change. The change that allows forming or producing a new substances. The new substance is really different from the old one. For example, burning piece of paper, it will be producing a new substance. How? At first we have a white paper, and then after burning the paper it will changing to the ash. That's mean we have changed, and the great change, it means that a new substance are formed as a result of a chemical reaction or chemical change. And right here we have more examples about the chemical properties. We have flammability, or the ability to burn, and we have reactivity, and also we have composition reaction, and also we have decomposition reaction, and also we have more chemical properties. I'm going to explain each one of them. So guys, the first chemical property is called composability. Composability is the ability to burn, and that means the ability of a substance to react with oxygen and release heat and light energy. Some of the materials, when they are burning, they will releasing a huge amount of heat energy and light energy. That's why those materials that have this capability, we call them composability. For example, we have wood, paper, charcoal, and other wood products are highly compositable. When a substance burns, its atoms or molecules chemically combine with molecules of oxygen. The substances produced are made up of same atoms as the original. The substances, but the atoms are arranged. For example, guys, methane is a composable gas made up of carbon and hydrogen atoms. When the methane C4 burns, its atoms separate and combine with oxygen atoms. Two new substances are formed, water and carbon dioxide. That means we have a new substance, that means we have a chemical change. The second chemical change is called reactivity. Reactivity is the ability of a substance to go through the chemical change. Reactivity, it means that the ability of the substance to go through the chemical change very easily. The elements in the first the elements that's found in the pictures below, that means they are highly reactive, or they are really reactive materials. And also guys, don't forget that the elements in the first column of the periodic table are very reactive, and they can be explode when they are exposed to water vapor and oxygen in the air and other substances such as noble gases. In the far right of the column of the periodic table, they will not have this reactivity look like those materials in the first column of the periodic table. That means we have different materials and different metals. Some of the metals are highly reactive. They will burn easily, they will go through the chemical chains, or they will go through the chemical reactions very quickly and very easily. That's why we call them reactive materials or the reactive metals. But others are less reactive, and they will not have the ability to go through the chemical chains or to go through the chemical reactions. Guys, please look at the pictures below, the chemical reactivity in action. Look at this truck. It has containing different types of oils and different types of gases and highly reactive materials. And in the second picture, we have also highly reactive materials. Also, they are reacting with the oxygen or with water vapor. They will go through the chemical change, or they have the capability to go through the chemical reactions very quickly and forming different and new substances. The third chemical property is called stability. Stability is the condition where a substance does not go through the chemical change easily. And we know that some of the substance that found around us, they will not go through the chemical change very easily. In fact, they are rarely react with other substances. There are many kinds of chemical reactions. One of them is composition. A composition reaction is an exothermic reaction in which the substance combines with oxygen. The reaction produces heat and often light, as I mentioned, but other substances, they are not going through the chemical change or through the chemical reaction. That's why we call them unreactive materials. Okay, unreactive materials or unreactive metals. And guys, right now I'm going to talk about the chemical change. Actually, we know about physical properties, we know about physical change, and we know about chemical properties. Right now we will learn about the chemical change. Examples of chemical change, right? We have striking a match releases heat and light and results in ash, smoke and gas. That's mean we have a new substances. Burning match give us a new substances and give us new shape, new color and new odor also. And also we have food rotting, especially an apple. For example, the apple are forming or producing the brown structure. That's mean it has an oxidation reaction because browning of the apple, it means that the apple goes through the chemical reaction with the air that's found around us. And also baking bread. Cooking bread changes the color, texture, odor, and taste. That's why we have a new substance. Nail roasting. Roasting is also an oxidation reaction. That's mean we have another new substances that are formed. And that's mean we have too much chemical reaction and we can observing them in our daily life. Guys, here's a task. You should solve it by yourself and please send me back your answer in a piece of paper. I'm going to check it. And the questions are just you should selecting A or B. Tell me, is this changes physical change or chemical change? So I'm going to read some of them. So sour milk smells badly because bacteria have formed new substances in the milk. This is an example of physical change or chemical change. Please solve it, guys. And sand flowing in an hourglass is an example of a chemical change or physical change. Please, guys, solve it. It's really easy. Guys, the last slide is talking about the questions that you should solve it. And after I finished to explaining the properties, so I will assess understanding by asking you really quick questions. The first one is how food can be protected from chemical change. How can I protect my food from chemical change? Or how can I prevent my food from oxidation with oxygen that's found around us? The second one, how are some metals protected from chemical change? You have a metal, you have your bicycle, for example, or you have different types of toys, and how you can protecting or how you can preventing them from the chemical change. How? And 3, how does freezing prevent food from spoiling? Guys, please solve these questions and send me back your answer. The number 4, Write 4 differences between physical and chemical change. Guys, today I mentioned more and more differences between physical and chemical change. Please write me 4 differences and send me. I'm going to check it, guys. And right here we have physical and chemical change. What are differences between physical and chemical change? Guys, compare the characteristics of physical and chemical change and then answer the questions below. So we have the physical properties, and also the change may be reversible. A new substance is not produced through the physical change, but in chemical change they are different. We have always new substances. And the last question is water cycle a physical change or chemical change? Please guys answer these questions. Hope you enjoy, guys. Thank you.